We are going to look at graphing a quadratic function that is written in standard form. We have y equals ax squared plus bx plus c. That's a standard form of a quadratic function. We're going to start really simple though. We're going to start with a being 1, b and c being 0, giving us this very straightforward equation, y equals x squared. This is going to be the parent function, and it will give us the parent graph. Let's start by picking some values for x, solving for y, getting some ordered pairs, see what happens. Table of values is a nice way to do this. X, let's do 1, 2, and 3. Y equals x squared. Well, 1 squared, that's 1. That gives us an ordered pair, 1, 1. 2 squared, that's 4. So we have 2, 4. 3 squared is 9, giving us 3, 9. Oh, why not? Let's go to 4. 4 squared is 16, giving us 4, 16. You'll notice we essentially just have numbers and their squares, and then we create a graph out of that. So let's graph it. 1, 1. We are right here. 2, 4. 1, 2, 3, 4. 3, 9. Well, that's 4, 5, 6, 7, 8, 9. Ooh, can I get 16 on here? 4, 9, 10, 11, 12, 13, 14, 15. 16. There we go. Well, this is not everything we need. We need a little bit more here because right now we only have part of what is going to be a parabola. We need to see what's going over here on the left side. So we'll put some more values in here. Probably ought to use 0. 0 squared we know is 0. So I have 0, 0. And now we've got to go to the negative numbers. -1. Be really careful when you do this, because if y is x squared and x is -1, since our base is negative, we keep it in parentheses. -1 times -1 is 1. -1 squared is 1. -1, 1. And let's put in -2. Same thing. -2 squared becomes 4. -2, 4. So you are noticing, I hope, that as we square the negative numbers, we're getting the same results as when we squared the positive numbers, because a negative times a negative is a positive. Now we can put these on our graph, 0, 0, and now we switch directions. As we go through 0, 0 are -1, 1, -2, 4, -3, 9, and way up here, -4, 16. This beautiful shape, once we draw the curve and connect the points, very carefully, like that, arrows on the end because it continues to go infinitely. This is a parabola. There are a couple really important features of a parabola. One of them is this point where it changes direction. That point is called the vertex. You might also know that this parabola is symmetrical. The right half is exactly the same as the left half, and if you plopped a mirror down here on the y-axis, the reflection of one side is exactly the reflection of the other side. The y-axis is the axis of symmetry. So this is our parent graph. We'll take a look at a couple other functions to see how we might have some modifications to the parent graph. Here's another quadratic function we can take a look at graphing. Y equals x squared minus 2x minus 1. And I already set up a table. A table of values is a nice way to keep track of our work. I find it handy so If I make an error with a calculation, I can easily go back and see where it happened, and it just keeps track of the arithmetic. What I'd like to do is use the same x values that I used in the first example, and we'll see what we get for the output values and the resulting ordered pairs. So I'm going to fill in the table -4, -3, -2, -1, 0, 1, 2, 3, 4. So those are some good numbers to use for our domain to start with. And we just start filling in the equation with -4. Remember, use parentheses for the negative number. -4 squared, that's 16. -2 times -4 is +8. -1, 24, 23. -4, 23. Wow. All right, let's do -3. -3 squared.
-2 times -3 minus 1. That's 9 plus 6 minus 1. That's 14. It's a more reasonable number. Y equals -2 squared. -2 times -2 minus 1. Let's see. 4 plus 4 minus 1. That's 7. -2, 7. -1. Y equals -1 squared. And -2 times -1 minus 1. 1 plus 2 minus 1. That is 2. 1, 2. Let's see. If I plug in 0, 0 squared minus 2 times 0 minus 1. 0 minus 0 minus 1. -1. And 1, y equals 1 squared minus 2 times 1 minus 1. 1 minus 2 minus 1. -2. And with 2, 2 squared minus 2 times 2 minus 1. 4 minus 4 minus 1. 4 minus 4, 0 minus 1. -1. 2, -1. 3 squared minus 2 times 3 minus 1. 9 minus 6 minus 1. 3 minus 2 is 2. 3, 2. And then 4. 4 squared minus 2 times 4 minus 1. 16 minus 8 minus 1. That's 8 minus 1 is 7.
4, 7. My apologies if the arithmetic went pretty fast, but I'm pretty confident that if you go back and look at these calculations, you will see where these y values come from. I'm simply putting the x value into the original equation for x, doing the computations, finding out what y is, and I get these ordered pairs. It will be interesting to put this on the same graph of our parent graph. So our parent function gives us this parabola. This parabola, if you remember, is y equals x squared. I now have y equals x squared minus 2x minus 1, and I will plot that with a different color. -4, 23, it's not going to fit on here. -3, 14.
That will. Here's -3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. -2, 7. There's that one. Oops, that's a negative here. -1, 2. 0, -1. 1, -2. 2, -1. Interesting, it looks like it changes direction right here. 3, 2. And 4, 7.
We go. So these purple points give me my second parabola. And notice it's in a different location from the first parabola. It's kind of like we took that parent graph and just moved it down and to the right a little bit and just plunked it down here, and there's a new vertex. Look at that. That vertex, where it changes direction, the vertex for this is 1, -2. That means this is being reflected across this symmetry line, which we call the axis of symmetry. And the axis of symmetry for this parabola is right here. The axis of symmetry goes through the value of x equals 1, and every line has an equation. So the equation of the line that gives us the axis of symmetry is x equals 1. If you notice that these points on the right side are the same distance on either side of the parabola, this gives us a pretty useful way to graph. This point is 1 unit that way, and that one is 1 unit that way. So if I go up here and I see 2, 2, if I knew that ordered pair, and I knew it were 2 units to the right, I could then plunk down a point 2 units to the left of the axis of symmetry. So all of these ordered pairs are the same distance away from the axis of symmetry. So right up here where I have negative 3 comma 14, that's negative 3 comma 14, 1, 2, 3, 4 units to the left of the axis of symmetry. I could go 4 units to the right of the axis of symmetry. And that means I'd have an ordered pair right there. Right here. And I could extend my parabola up that way.